Oh, I think we were actually switched over by accident. I wasn't in studio mode when I was fixing the camera, so we've been live this entire time.
Oh my God, they've heard our inside chatter. This is
Yes,
terrible.
we said negative things about OBS, a piece of software that not only enables the stream, but we did not pay any money for.
It's whatever. It deserves the
I
negative
think
comment.
no,
It
our true
sucks.
colors have been exposed. We're just shameless. Yeah, we're just shameless coattail riders.
Yeah,
You know.
I love corporate software and closed source.
Yeah.
It's really my priority in life.
Yeah. Um, the guy who runs OBS, shout out to that guy, whoever he is, because there's a lot of
I'm sure
people
he's
that
very
like rip
nice.
off
Yeah.
his software, but like I think so much his software is like load bearing for like an entire piece of the entertainment industry.
It's very
And
much that XKCD comic, right? Yeah. The OBS is that one weird project maintained by someone in Idaho.
are we speaking out of turn here? Like I just let's actually resolve this. Sorry, folks. We're here to do Advent of Code, uh, to finish a couple of different problems for Advent of Code. We're already past the last day. Yesterday we finished. I believe we finished day 11 very quickly. We were a day behind because I had a holiday party to go to. Then we started on day 12 and got a decent amount into it and then weren't able to actually finish it. But we also have a backlog of a couple of the harder problems. I believe it's the second puzzle of day 9, second puzzle of day 10. We have a hypothesis on how to do both of those things. We're going to try to do everything today. We're going from 10 a.m. to 12 p.m. Pacific. Unless we want to keep going and just power on through, we'll see how we feel. But
We'll see. We'll see.
first of all, we need to figure out who made OBS, right? OBS. Lane Bailey. It says original author. Maybe it's just a big group of people now. Many
I mean,
online
to be
collaborators.
fair, I feel for Lane Bailey, who apparently accidentally made load variant software for the internet, like,
Yeah.
and probably just wanted to stream Twitch.
Like, does this dude have $100 million? Because he kind of should, right?
That's a
I mean,
that's a
we
good
we
question.
we all should, right? But like, especially this guy. Um, I don't
Oh,
know.
she they. I think Lane is a name change.
Okay.
FYI.
Well, they do have a Patreon
Mhm.
with $2,500 a month.
And if you go to the Open Collective, this is supported by Logitech. Has given them 50 grand.
Okay.
Someone's given 100,000 incognito. So, like, I mean, to be fair, this is a low grade piece of software on the internet and seems to be run by a lot of people. I think it's just impossible to write, like, it's video capture software that's like multi-platform Linux native. It just sounds like a nightmare.
It's an incredible achievement, right? I think we were just talking about in
Mhm.
our Discord about how hard it is to make multi-platform software. And I was defending the Electron project. I was like, why do people complain about Electron so much? Especially like professional software engineers are like, oh, Electron's slow. Why would you do that? It's so easy to like use Swift UI or whatever. Have these people worked at an actual company? Like, it takes so much effort to support like different platforms, right? It's just such a weird claim to
I
me.
I mean, I think you end up here accidentally.
Okay. All right. Well,
written in
let's.
C++ and built with Qt. Ugh, that
OBS
hurts.
is
Yeah. Uh-huh.
interesting.
C and C++. I wouldn't want to maintain that. Good for them.
No, it's challenging. I guess Qt or Qt, I think it's called, does handle some
Oh,
of the
obviously,
cross-platform
yeah.
stuff for you, but still, it sounds like a nightmare. You have to test all the different platforms. Yeah.
Ugh.
Okay, so just to recap problem 12. We're going to start with problem 12. We're going to go backwards, right? We're going to do problem 12, problem 10, second problem 10 if we get to it, second problem of day 9 if we get to it. So to recap the problem, we basically have these areas under a Christmas tree. One of them is 4 by 4. I'm using the example right now. The real problem input is much more complicated than this, but we have these areas under the Christmas tree that are just like two-dimensional grids. And then we have this weird set of numbers afterwards. And it's basically saying which specific presents must go in that area, right? And in this case, it's saying that we need 2 of the 1, 2, 3, 4, 5. This is the 5th present but it is index 4, so it is. I'll call it present 4 because there is a present 0. And we need 2 of those, and that's it. And that just goes under the 4x4 area under the tree.
Yep. Yep.
That theoretically should be impossible, right? Because these things are 3x3 as it is, right?
No, because present 4 nests within itself.
Oh, I see.
So the first 2 rows
Yes.
are possible. The third row is impossible.
Okay, right. And then there's 12x5 and so on and so forth. And the presents also have this shape here, right? And then if we take a look at our actual input, we actually have many more regions under the tree that require a ton of different presents. And then we have these shapes here. So the thing that Dom and I have implemented so far for this is essentially an algorithm A to just like parse this really annoying input, right? And the way that we're representing the presents right now are as this type right here, which is a 2-dimensional array of Booleans. Does the present it's basically, these are 3x3 arrays, and we're asking the question, does the present have something in a particular grid point or not? That's what the Boolean is representing. And then we have a type that represents the region, which is basically the dimensions of the region. How wide is it? How long is it? I'm not sure which is width and which is length. Is width going left to right and length up and down, or vice versa? I don't think it matters, right?
I assume so, but yeah, I hope we can write it in a way that we don't have to care.
So one thing about placing these presents into the respective regions is that you can rotate them however you want. And because of that, it doesn't really matter whether width goes left to right and up and down or what, right? Because everything's like going to be a rotation of everything else. So we have an algorithm here. We actually have a lot of annoying parsing code. We have an algorithm here in the solver, which basically tries to place. We take our list of presents that we're supposed to place, right? And so every region has this essentially order list of what presents are required, and we're just going to go through each present and try to place 40 of present 0. And if that works, we're going to take all of those possibilities and place 43 of present 2, and so on and so forth, right?
Yep.
And then all of this is kind of baked into this big recursive loop. And we're also not only going to attempt to place those presents in every single position, we're also going to try to place each one in every single possible rotation. And so this is going to add up to a lot of recursive possibilities. In fact, as I talk about this out loud, it kind of feels like we don't have enough like pruning happening in the recursion.
That's what I'm wondering about. Yeah. We'll see. We'll see. I wonder if there's a way to, like, once we've placed 40 present ones in this example, if there's a way that we can flatten some recursion. Yeah.
Yeah.
If we're doing every possible configuration of that, then one of those must be a solution if it exists. So we can like drop the stack.
Correct.
But I assume there's a lot of possible configurations of that.
Yeah. So one function that we haven't really written yet is how to basically create a new, essentially, board that is not 100% empty, right? We basically, like, when we do this recursion, we need to start from somewhere where other stuff has already been placed, right? And we have not written the code that says, like, okay, given a current state of the region under the tree, give me this shape, and then at this position and with this rotation, put it in there and give me like what the board looks like after that, right? So that's this attempt place function that maybe we can finish writing. Why don't we do that? And then, I have God rays on my face.
That's great. Yeah.
Can't be avoided.
So fancy.
Yes. Paid a lot of money for that. So why don't we go ahead and fill this one out, and then we can maybe talk about optimizations. Okay, so our representation of the board was a little bit controversial, I think, last night. Or it just wasn't super obvious, right? So one way that you could represent the board is just like a pixel grid. So it'd be another 2 by 2 array with booleans, right? Is there a piece of a present somewhere, right?
Mhm.
The way that this particular one is filled out is it's basically we assume that everything on the board is empty at first, but then we get this list of individual points in the region that are occupied with a piece of a present, right? And that is represented as a set of strings. And then the string here, I think we're using string because it's a limitation of JavaScript, where JavaScript is not really going to let us put like, it's not going to be able to do the set deduplication mechanism unless we use a particular type, runtime type that it knows about and knows how to deduplicate specifically. So that's why there's a string there. So what we do is we take a 2D coordinate, and I believe our serialization format is a comma, right? We take a 2D coordinate, we stick a comma between the x and y coordinates. Similarly, for deserialization, we just split along the comma and then parse it back into a number. It's a little bit annoying. So what we're going to have are occupied coordinates. I think we're just going to go through all of the things in occupied, and then we're going to loop over that. Actually, we don't need to do this. We can when we want to check occupation, we'll just serialize the coordinate that we're trying to check, and then check it against membership of this set. Does that sound right?
Yeah.
Okay.
Yeah.
Okay, so first of all, we get the rotated shape. Is that right?
Mm-hmm.
And I believe we have a rotate. And then we take the present, and then we pass in the rotation. And then we are going to have like a new occupied set, right? And this is going to be I'm just going to basically have the serialized positions of the rotated shape placed where they will go. And what we can do is we can just say for I guess we're gonna do like the shape is like the rotated shape is 2D array, right? So we need to go for const rows of rotated, const, and then for const call of rotated of rows. Right, rotated itself is like a list of rows, right? And then we're in the column, and then this will be true or false, right? So if it's false, we don't need to do anything. We'll just keep going, right?
Mhm.
Otherwise, if it's true, then we're gonna get the coordinate string, and that will be serialized coordinate of. We need actual indexes here, don't we? So that means we need to do something like this. I mean, theoretically, we know it's 3. Do you just want to hard code it?
I'm okay with that. Yeah.
Okay. We know that because all the presents are the same size. Sorry, 1 second. We serialize I. Is it J and I? Is it? Do we do X first? We need to be consistent about this.
Yeah, this is where it matters. I thought we've been doing.
Where else did we serialize? Where else are we serializing coordinates? Serializing the region. Oh, we have not really decided which goes first. I think this is the first time that we've actually tried to put something into a string here.
Is this the first time it matters? I guess so, because we haven't, right. We were on this code, but nothing's actually been added to the board yet. So
I think we can do X then Y.
Okay.
As long as we're consistent about that, then we're okay, right?
Yeah. Yeah.
Then we do if occupied has this coordinate string, then we cannot place it, right?
Now this is true. Yeah. 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 Okay. Right. Right. Because we're updating
Otherwise,
the set. We're updating the set. Yeah.
we add the coordinate string to this at the end.
Hmm.
And then if we get out of the loop, that means we were able to push everything on there from the present. So we just need to add it into occupied, and we need to return a new thing. I think we need to clone this. Is that right?
Next occupied. Probably looks like it. Yes.
Yeah. Okay. Great. So we return a clone of the set. Can we do this new set of occupied?
Oh, hell yeah.
How do I think the bulk add is really dumb, right? I think it's literally just like
Hmm.
of serialized
Hmm.
res.add chord return res.
Well, oh, and these are already serialized. Right. 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 Okay.
Yeah.
Cool. Yep.
And then we're not using x and y. Oh, we need to do x plus j. Is that right? And then y plus I.
Correct. Yep. 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 Yep.
We're essentially doing a collision detection, right? This is more or less what this algorithm is. Okay. How does that feel to you?
I think that's right.
Okay. So I guess we can just try. We now have a complete program. We could try running it on the example and seeing if we get the answer 2. That seems like
We've got one more big to do here. Is this just optimization visited including presence?
yes. Okay, that's true. Okay, so I think this is like our attempt to start thinking about pruning. If I actually just got rid of this visited, would this return the right answer? Right.
Good question. So yeah, let's find out.
3. Okay.
3 is incorrect.
3 is incorrect.
Dang.
So this is good because we know which one's wrong, right? We know it's which one's this? It's the second one.
Yes.
Okay. Let me.
We could try printing. We could print the board state that it thinks is final?
We could. Let's do that.
I feel like printing board state here might be instructive anyway.
Okay, so this is going to be, I think, kind of an interesting. Did you leave the VS Code collaboration?
I did. Yeah, be right there.
Okay, that's fine. You don't have to be there if you don't want to. I don't. I think
No,
this
I do.
this stream is all about freedom. You know.
No, I just wanted I couldn't see your terminal output.
Okay. So the region is a bunch of coordinates that are occupied, right? So this is actually slightly annoying. I think we can deserialize a region right now. Do we have that? We have serialized region, so what we want is function deserialize region.
Mm-hmm.
Oh no, we need to basically just expand this into a list of 2D coordinates, right? It's kind of annoying.
Yeah.
So we'll do const chords equals, and this is the set of occupied things, right? So we're going to do r dot map deserialized chord, right? And now if we're going to print a grid, we need to know how big the grid should be.
I was gonna say, I think we need the region in here.
And then oh yeah, we could print the dimensions there, can't we? Width, length, width number, sorry. And now we have to make a decision on whether width is left or right or up or down. I'm going to say length is up and down. Is it better for us to just use the word height everywhere?
I mean, probably.
Okay.
It's what we're using length to mean.
Yeah. Okay. So rather than doing this, so what we do is we just say for let I equal 0, I less than height, I plus plus. For let j equal 0, j less than width, j plus plus. And now we're going to print a row, right? Do we want to accumulate this in a string, or do we want to print each row progressively?
I think just print. Do you want to just print line per row and?
Okay, yeah. So basically, we have like this row string, which is equal to. How do we do? I guess what we'll do is we'll do it. We'll do this the old-fashioned way. The row string will just build up incrementally. I was trying to think about how we could do it within reduce, but it's annoying because we're iterating over indices here, right? So we're gonna say that like the chord string, like basically if r dot has the serialization of our x and y coordinate,
Yep.
then row string plus equals this. Otherwise, row string plus equals the dot. And now that we're done with that, we console.log the row string. And that's it.
I think that's it.
Okay. Okay. Where do we put this, Dom?
Let's see. Should we just put it after? I guess we should put it in solve, huh? Because that's where we got
so
our cache
what I'm going to
of.
do is I'm going to update our example and get rid of everything else except the second input, because I think that's the one that is breaking. Is that right? That's the one that shouldn't be in there?
It should be the third input, but let's run it on the first one too. Let's just see success.
Okay. I'm going
The first
to
one- the first one's very
just
easy
so
to
we don't
verify.
spam
Yeah.
ourselves, because this is a lot
Yeah.
of recursive calls. I'm going to go ahead and get rid of those. Oh, we didn't put that anywhere, did we? Why does it now show 0 as the answer?
That's a little concerning.
It is.
How did we go from 3 to 0? Did we change any logic?
I got rid of the visitation logic.
No, but that we ran that and got 3 still, right?
Are we reusing state between our? No, it's now 0. And then if I uncomment this,
I thought we didn't run this uncommented. Bro, what is happening? I hate it.
yes. I'm pretty sure we didn't change anything. Did we?
I can't access the terminal, but can you? I just logged regions in there. Yeah. Okay, we're not parsing any regions. Is what's happening.
Oh, I changed the word height to something different.
Oh, there you go. Yeah.
Lines dot
length.
length. Okay, yes. Anytime we have dot height. I think we're good.
Yep. It was just that. Okay. So now. Okay, cool. We got regions. Delightful.
So you don't have access to the terminal right now? You can read it, but you
I
can't.
can read it, but I can't. I can't type. Don't know why.
That's funny.
I requested access.
Sorry about that.
Eh.
I'm gonna turn
This
on.
is not your problem. This
I'm
is.
gonna turn on my space heater.
Ooh, good choice.
I said that away from the mic. I just turned on my space heater. We'll see what happens. I might lose power. Like the breaker might, but it's so comfortable. Why do I keep following you? It's kind of this weird thing. Command Alt
Oh,
F.
that is.
Do I accidentally press that? I didn't press anything. I think you focused me.
Oh, yeah. You know what? I think there's a button for that.
How do I
Sorry.
do that? Focus participants.
Huh? Or follow participant.
It
I'm
says
unclear which
Dominic
is
DeGrati
which.
focused your attention. Thank you, Dom. Did I?
Wow.
That's condescending. um, what are you pressing to do that? Is it the little shout,
I think
loudspeaker
it's the
button?
shout icon. Yeah.
Okay. What are you
Yeah.
pressing
Here,
up there
shout at me.
that does? What else are you trying to press up there?
I'm looking for a way to re-request terminal access,
Oh, okay.
which seems impossible, which is very funny.
You know, I feel like I should just be able to give it to you.
Hmm.
Like, oh, and it's so funny. I just followed you. I think that every time I try to click on you as a participant, I just follow you. Luckily we have this chat window here on the side. It's really good that we can chat with each other. Um, live share, list participants, show shared servers, stop collaboration session, focus on help view. I
Share
literally
terminal.
can't do it. What's that?
Share terminal.
Oh, there we go. Read write. Oh
There we
yeah.
go. Okay. Good
There
to
we
know.
go.
Good to know.
Oh, and it starts
Cool.
bash. Why does it start bash?
Bizarre.
It says bash,
Totally
but
bizarre.
it's got my full like Z shell prompt and everything like that.
Oh, that's really funny. Yeah, it looks it looks like seashell.
I confuse. Yeah.
Cool.
I started
Okay.
adding the local time to my PS1. And I quite like it.
I like that. I like that a lot. Yeah. Okay, so what are we trying to do? We're trying to.
We're just trying to print out what things look like, right?
Yeah, so
And
this was show region. So like we can just show region.
and I'm gonna get rid of the other two examples just so.
Yep, yep.
And then did you add the print in there? Should I run it?
Oh, sorry. Hang on. Yeah, I'm just adding because I wasn't sure what the. So this is just printing the final state of the board. Yeah, give it a run.
Okay. Okay, that's interesting. I think that's wrong, right?
Yeah, that is just incorrect. So that's why I wanted to run this example because at least we could very easily see they need to be offset, and it's drawing the extents of four on top of each other. Cool.
What does this look like? Oh yes, they need to be offset from each other. Okay, so we're like missing some math, right?
Yeah.
As long as we
that
believe
makes
that the
sense.
show region function also is written correctly, right? I suppose that's a kind of a critical thing to think about.
I'm choosing to believe it is because
'Cause
we're
it's
getting
simpler.
a 4x4 thing. Yeah. That was not the function I was worried about.
Okay, so maybe we do a show region after we've done the attempt to place, right? We can do that. All right, console.log. Or we just show region, right? Of res. And then we just know that it's 4x4, right? Okay, the first one goes in there. And then it's funny, the second recursive call is not consistent with the first one. Like, why is it that the second recursive call now basically... Oh, never mind. We need a new
immediately
line at
placing
the
it
end.
there?
We need a new line at the end.
Oh yeah, okay.
Just to make things a little bit cleaner.
Too many new lines.
Too many new lines. I think the new line is actually down here.
Yeah.
Okay, so we're just like placing it incorrectly. So our deduplication logic is wrong, is it not?
Yeah.
Like
Or like
our hit detection is
our
wrong.
check is wrong. It's rotated it. Is it our hit detection or is it our placement? Because like, have we figured out?
Our hit detection is our placement, right? It's the
Oh,
same
that's
thing.
true. That's true. Right. So we're just attempting place.
Um,
It's weird to me. So okay, so we must be so we're at like rotation 2 here. I'm curious why we're not seeing other placement attempts. Oh, I guess because we're not showing undefined. We're not showing these failures. So this is our successful. We've rotated twice and think that we can overlap. Okay, that makes sense to me.
um, yes. So our placement attempt,
Mhm.
the hit detection is just wrong, right? So
Yeah,
it's
I
this
think so.
stuff. Uh,
I want to posit that rotation could also be wrong, but probably not.
we
That
can
seems pretty
test
straightforward.
rotation really easily, right? In fact,
Yeah.
let's go ahead and move this out of the solver because it doesn't need to be there.
Mhm.
And then
Oh, true. We can just call this with some
and
shapes and output.
then now we can do function print shape.
Mhm.
Same kind of deal, right?
Yep. Yeah, I mean, almost the identical function.
Is it the identical function? Can we just return? Oh no, because we're not doing deserialization or anything like that. Yeah.
Correct. Yeah, yeah.
Okay.
You could copy paste some of it, but
Yeah.
not all of it.
Else. It's just console.log.
Mm-hmm.
Or should I actually add an extra new line here? It looks like console.log gave us 2 new lines, which is more than I wanted. So let's just do console.log. And then I'll do the same thing with show down here. Okay. All right. Row string should be a let. Undefined, undefined, undefined.
Oh, you're console.logging undefined, I think. I think you just want to console.log an empty string.
Oh, that. That's surprising to me, but you know what? It makes sense.
All right. Well, I just logged out the 4 rotations of shape.
Hang on, I need to clear the buffer because we're seeing the old stuff. It's still printing out undefined somewhere.
Oh, that is weird. Yeah. Huh.
Is row string is definitely defined. It has to be defined.
It sure looks like it. Yeah.
Is there another console.log somewhere?
I comment that out. Does that go? If I comment out the empty string, it doesn't go away. So that's. Oh, you know what? I'm console.logging print shape, which I'm logging a undefined return value.
Oh, okay. Yes.
Yeah. There's a very reasonable undefined to log. So actually, maybe empty string doesn't. You can just console log without empty string. Indeed, you can. Okay, so that rotation looks correct to me, which is good. I just wanted to verify that we weren't messing that up.
Okay. Why don't we do it for every shape?
Before, yeah.
I'm fairly convinced it's fine. I think the rotation code looks good.
I think so too. I think so too. It's nice to be able to peek at different parts of this, but I am
Okay.
much less concerned about this. But thank you for helping verify that.
Yeah. Okay. All right.
Okay, so back to placement, which is
Yes. So we stare at this for a little while. The rotation code we know works correctly.
huh?
Serialization. This is the output, right? So serialized is just like. I'm actually just gonna call this. New chords. This is just like stuff we're adding to the new region, right?
Yeah.
And occupied, I'm just gonna call it the region because that's what. So maybe we can. I mean, we know what the region looks like coming in, right?
Yeah, but I mean, I'm
Let's
curious,
actually
like-
use our print region thing here because I think it's gonna be hard to understand otherwise.
a little bit. Yeah.
I mean, we're not updating region in this inner loop, right? We just need to print it out once, I think.
Correct. Yeah.
Show region up here.
Mhm.
Oops. Why is this not happy? Oh god, it needs to know the height and width of the region.
It's part of our input. It's in the.
Yeah, but it's not available in this function.
Isn't it on region?
No, region is just the list of occupied.
Oh, sorry, because we had a
Yeah.
region type. But it's on the solver. This dot width, this dot height.
Oh, okay, that's perfect.
Yeah. Yeah, the solver is an object, and that's a good choice.
Okay. Oh shoot, we still have this extra console log. Let me open this. I'm starting to feel claustrophobic here, so.
Yep, reasonable.
Oh, we don't need to print out all the shapes anymore, right? I think we're relatively
we're good.
convinced that rotation is correct.
I feel fine with that. Yeah.
Okay, we place that board. Okay, yeah. So the region is fine, right? It's just whatever we're doing in here to place it and do collision detection is wrong.
I think that's yeah.
Are we mixing X and Y again? Like,
I was wondering that. Yeah, is this Y X?
uh,
Nope, that's worse.
yeah, I don't think that's right because now we're definitely mixing X and Y within the addition here.
Mm-hmm.
What is could not apply refactoring? What does that even mean? We serialize the coordinate. I mean, that's totally fine, right? You know what? You were right to print out what this thing looks like. Why didn't this take? Oh, it didn't save. Okay, so 0, 0, 1, 1, 0, 2, 0,
2 0.
0, 1,
0 1. 0 2.
2,
1 2 2 2. That looks
2,
that
2.
looks correct.
Yep.
So can we?
I mean, let me just go in here. Are you
I want
typing?
to see the new chords we're adding. I am sorry.
Okay.
I want to log new chords after we've decided to add something.
Okay. Did you run it yet? Oh, you don't can't run it. Sorry.
I can run it. Yeah,
You
we fixed it. We
can.
fixed it.
Oh, we fixed it. Okay, so
Yeah. So that's seven new coordinates. Three.
where are we?
Well,
Where are
straight
the
off the
new
bat.
cards being added here?
Uh,
It's a little bit of a confusing spot because
totally. It's just like it's after we decided that something is valid to be placed.
let's stop printing as much. I mean, the thing is, it should be pretty clear where it is. It's just that it's an
Well,
array. Um,
yeah. I mean, just if you look at the bottom here, these coordinates already don't make sense. 3, 0 is not even in the shape that we're applying. Do you agree? That should be like the bottom left dot.
yeah. I realize we're also
So first
not
of all,
doing a dimension check. So that's another thing that we are doing wrong.
yep.
Um,
Oh, oh.
but that's not the problem right now. It's not the same problem that we're trying to solve.
Wait. No, but it could be. Are we drawing off the right side of this grid? Dimension check actually could very much be the problem.
Oh, you're right.
Yeah.
Yes, because
So
the
there we go.
first rotation, the first rotation will do something like this. Right. I think we mistakenly thought we were just like overlapping, but we're not.
Exactly.
Okay.
Exactly. In fact, we're drawing two unrotated shapes next to each other. Okay, great. That makes sense.
Okay, so there is an easy way to do this. Well, we don't know we don't know the full width and height of the actual pixels here, so we'll just add the dimension check.
We do. It's x plus j and y plus. We know if these coordinates are in bounds.
No,
because
what
of
I was gonna
the-
sorry, I was speaking out loud,
Oh.
and I omitted the half of my thought process, which is that it would be nice if the shape just knew how wide and how tall it was.
It's 3 by 3. I mean, we can also just
It's
say
not
like,
3 by 3. Some of them. Well, are they all 3 by 3? I guess they
I
all
think they're all
are.
3 by
Okay,
3.
yeah. I thought that some of them would be.
I think there's
Partial.
no situation. I think there's no situation where anything could be placed in the fourth. Like in this 4 by 4 thing, a shape could not start on.
They all
column 3.
occupy the full range of 3 on the horizontal axis and the full range of 3 on the like. I thought maybe some of them were like
Correct.
2 by 3, and they were just like. Do you know what I'm saying?
Yeah.
Yeah.
Yeah, totally. So I think we can just say like, yeah, there's actually like a bounded range for what x and y are acceptable placement checks.
Yes, exactly. So maybe what we can say here is like if up here,
We could even do this
dot
within
height
the.
is
We could do
less
this in
than.
solve. Actually, we could do fewer iterations. Like we don't need to enter this for width minus. We could do I less than width minus 2 and probably be fine, right?
Oh, you're absolutely right. Yeah.
There's like entire placement space is just out of bounds.
Yeah. Yes. Let's just do it. Width -2, height -2.
It's either -1 or -2. I'm not sure, but yeah.
Well, what -2 means is if it's -1, you're leaving a clearance of 1.
That's right.
So it might be need to be
Okay.
-3, right?
No, I think since it's less than, not less than, or equal to, we were already.
Okay, it's -2. We were already leaving 1.
Yeah.
Okay.
We're already using the last row correctly. Okay, so let's run this. Yeah. Fuck off. Really?
Well, we still need
I'm
to
still
check
seeing-
because it's still trying to place down here, right? It's still. Well, no, it should be stopping, right? It should only be trying to place.
It should really be stopping. Yeah, I'm confused by that.
Attempt place I and J.
Huh? We just
Well,
shouldn't see
I
the
see one
numbers
problem.
2 or 3 here.
I see one problem. We're
Yeah.
mixing X and Y over here. This should
We
be
forgot.
height.
No,
this
look.
should be width.
J plus plus, I plus plus.
Oh, yeah.
We did the thing again.
We did the thing again.
Yeah.
Okay.
Cool.
And
All right.
then attempt place. Oh, you know what? It doesn't matter. This was actually correct. I'm just mixing my my notation here. I think we should just try to be consistent and always use J for the x-axis and I here.
Okay.
And in fact, let's actually just literally fucking use...
X and Y. Yeah.
And am I
concur.
using I and J anywhere else?
Inside attempt place, but we have an X and Y there. You have to either go XX or YY or just leave it.
Okay. Yes, I'll leave it for now.
Okay. We're doing X plus J though, yeah. That is correct. Great.
Okay, fantastic. Okay, so
that-
the example...
That's two interlocking U's, yeah.
We'll just add the other ones back in there and see what happens.
Huh.
We're going to get a lot of print output, I think. Yeah, it might be prohibitively slow. So let's get rid of the prints, if we can.
Cool.
Let's call this print region, just because...
Did it even finish? No, we got an error.
I mean,
on 30.
no, I mean, I control-C'd it, because it
Oh,
was
you
just,
killed it.
it
You
just
killed
kept
it. Okay,
going. Right.
Ah, interesting. I think when you control C, I just lose terminal access. That's fascinating.
Oh, is that what happens? I mean, you're adding new lines. I can see it.
Can you?
Yeah, I can see you adding new lines.
Oh, weird. I've totally lost my visuals on this. We'll see what happens if you run it again.
We still have a console log somewhere. Oh, this one. So it's running like infinitely right now. So even already we need pruning, right?
Well, so I think what's happened. Those first two examples are outputting and print solved really fast. The third one is the unsolvable one. So I assume we are not terminating correctly when there's no condition that fits. Does that sound right?
Right. Okay. So solve.
And our visited cache is still missing, by the way. We haven't done any pruning yet, though I think this should work.
Okay. So yeah, I see what you're saying. So basically, if every one of these things is 0, then we return true. Otherwise, we'll decrement 1. Well, I mean, we should not be going infinitely, because line 191 means we're done.
I agree. Because presence, we're creating a new copy and sending it down. Next occupied. Yeah, that's confusing, but I feel like that's, yeah, I don't know. We could take the passing cases out if we want and maybe put some logs in here and just see if it's spinning on something.
Sure. Is it the last one?
It's the third, yeah. Third example should fail.
Okay. What happens if it doesn't have ability to comment this out?
No, and we'd have to parse that out of our input.
I mean, that's what I was going to do, but, Okay, so we're now doing this last thing. How do we want to do this? If we start console logging just the easy stuff, we're never going to get there if we console log early.
Oh, I just want to see if there's a loop or something. I want to see if there's a condition that is just not getting satisfied for some reason.
Okay.
We should just see infinite console logs or something else.
We don't know if it's infinite or not, right? The distinction between deep recursion and an infinite loop is you have to check whether or not you've done something before or not, and that is actually the same thing as our visited thing, right? Literally, we in order for us to check for an infinite loop, we can implement this pruning thing, right?
That's true, and we could do that just as a log. We could log if we're at a visited spot already again. Maybe that would help.
Sure.
We could just add it, and rather than returning false, just say oh, we've been to this state before.
Yeah. Okay, so the reason why this to-do exists, okay, I think we didn't quite fully talk through why this to-do exists. So what we're doing right now is, in order to basically not... A lot of recursive problems, you need to make sure that you don't retry solutions that you already had attempted to solve, right?
Mhm.
So you memoize, and this is the memoization. And the memoization we have right now is that when we get to a particular recursion, we have like a particular like arrangement of presents already there. And right now we are only serializing what the thing looks like without regard to which presents have actually been placed. Right? And so this is just saying if the bird's eye view under the tree looks like this and we've already been here, then don't continue, right?
Yeah.
But I think what I'm saying is that like you can get to the same looking thing in multiple ways, but the way you proceed from there might be different in different situations because the number of presents that you need to continue to place, and because those presents might be different, you're actually in a different situation, right? Does that make sense?
Yeah.
Um,
Yeah, you could have gotten there through a different set of presents.
so this
Very
is
easy.
kind of annoying. So
Yeah.
visited really kind of has to be some other sort of thing where we serialize the presents and then add the serialized region on top of it. But then, if we do that, is that actually impossible? Like, will we ever hit that dedupe? I guess we could just in practice just try it. But because
Yeah.
we are deterministically like going through each, we're placing the first present as many times as we have to first, and then each recursion is going through every particular X. I mean, the only time we're going to hit that is when we do the mirror image cases. Does that make sense? I think that's the only time that this deduplication is going to help.
Yeah. Of which there's basically just one mirrored shape, the
Yeah.
H.
I mean, we could add it in there, and we could just see how many times it deduplicates. But I think it's just going to be for the mirror images, right?
Yeah, I think that's right.
Okay. I'm going to call it like the visited key, and what it's just going to be is it's going to be like presence dot join question mark comma plus colon plus serialized region occupied.
Yep.
And then I guess we can console log if we're doing this. I just want to see what happens, right? Does it ever hit that?
Totally.
Yeah, I mean, it's hitting it. Decent amount. I don't know if it's going to make a big difference, though.
Was that continuing to print or
It was. I don't know. That's a good question.
okay? I still have a suspicion that something about the failure state is an infinite loop, even though this code looks correct.
Yeah, so another thing we can do is we can do console.log presence. And I think this is just going to be stuck on the same thing for a long time, right? It's actually placing at the end. I thought we were starting with the first one. Not that I don't
We
think
are.
it matters.
It's already been placed. Like the first two have been placed, and it's struggling to place the final set. It's like it looks like it's flapping on the back half.
Okay, maybe.
I don't think there's this many rotations to be had. Like I
Yeah,
think this
yeah.
is
So
more,
you think our exit condition is bad, right?
yes, I think this is more cases than should be possible for this small state.
Yeah. Okay, that's a good intuition.
We're only placing 7 items on a 12 by 5 grid in 4 rotations. Like
Yep.
now how do we determine why this is happening though? Like we are we're taking presents, we're decrementing, we're returning false. We can't solve it. We pop back. Can we create
So
a smaller unsolvable example? Like we should all do with the 4x4 grid on like any two presents. Only present four can be put twice there.
okay, so something like this.
Or like put a third, yeah, put any, yeah, that should, oh, you know what? That might be possible. That has a valid rotation.
Okay.
So put three of them. Yeah. So this should be fully unsatisfiable.
Okay, that is.
Fuck. And finished. Okay.
I think maybe the issue is that there aren't. Well, it could also be that there aren't that many rotations for this last case, but there are many, 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 many possible ways of getting to that leaf situation, right?
Mm-hmm.
Right, because if you think about the multiplication, it's just the actual kind of like dispersion of this thing. The recursive tree is really, really big, right?
Yeah.
Yeah, which makes me worried about the actual input. So where I think this problem is going is that they are going to want us to come up with minimal pre-combinations of these presents that the problem is going to reduce down to, right? Because
That makes sense. Yeah.
which is horrifying.
Just a bit.
Yeah.
Yeah. How, God, there's 1,000 of these combos. Jesus.
Is this okay? We call solve here. Let's say we like this last decrement takes it down to 0. We attempt to place it. It does place correctly, and if it's not undefined, we call solve again. And then we do this check here. I almost think this check either needs to happen up at the top, or it happens inside here. I mean, it's not incorrect where it is right now, but we're doing like a bunch of wasted work, or we're doing some wasted work. Although it is true that once we hit this, the whole thing's going to terminate, right? We're going to like jump out of the search. So maybe it's fine where it is. I think at a minimum, like this just goes to the very top, I think.
Okay. Yeah, I mean, it seems fine.
Yeah. Because like, why bother checking visitation if you've gotten a correct answer, right?
Yep.
And this is easy to verify. Yeah, I still am skeptical that we have that many possibilities, right?
For that one, especially that it was sort of flapping on the last two presents in that like I didn't see it going back to the start, and I'm confused. It was like rotating one present infinitely, I feel like.
Yeah, and like why what did it look like again if we just log? Where were the logs? Oh, I think the log here, this one is actually, it's fine. So I guess let me go back to the original state, which was this last one. Is that right? Oh, shoot.
Yeah.
Hang on a second. Does this ever go down?
No, I don't think
It's
I
always
think it's
two?
I think it's failing earlier, yeah. Like what I'm seeing is that it's not able to place that final present.
Yeah.
Or like maybe it places presents spot like the fifth column, but it's always failing to place that other column. Yeah, is there any state we could output to like?
I mean, we can print what it's trying to place, right?
Yeah, yeah.
And we could restrict it to when the first four are zero, if we want to like limit the
Mhm.
output.
I was like, yeah, it just doesn't smell right to me. I don't know why.
Yeah, it feels okay. Like we're deduplicating at the level of solve.
Hmm.
Is it possible that you can come to this loop here multiple times with the exact same?
Like input. Huh.
You know,
Maybe. Gosh.
I feel like it's not. I guess that's the hard time. Is my intuition tells me that this is correct right now.
Yeah,
So maybe I think just to go back to your question, like, are we trying the same thing over and over again, right? Um, and well, we do have some deduplication here, right? We have this thing,
Mhm.
right? Which is saying that if a region looks a certain way, and the number of presents that we have to place looks a certain way, then and we've already gotten there, we're gonna return. And this we've established that this I think this deduplication here really only happens for mirror images, right?
Mhm.
Um, so the only other possible duplication that we're having is that within that constraint that we're not deduplicating, we're somehow able to like call the recursion again on the same things, which would imply that this was like a wild true with a bad break case, but I don't think it is, right? This has a finite number of things it's gonna do, and it'll be done, right?
Yeah. Do you want to just run it and see if it finishes? I'm kind of confused that it is going so long, but like
Okay, yeah, we can run
just
it.
let it go while we're doing this at least. Yeah.
Okay, oops. Why is this going back to ls? I never typed
Oh, because
ls.
that's my default. Like, do I have access to the terminal command? I'm
Okay,
sorry.
got it. Yeah. No, it's don't worry about it. I think it's just that we don't have our separate. We're sharing weird state, right?
Yep. Okay, so it's just running forever. Great. Love it.
Yeah.
Huh. I don't think there's enough cases here. This is so bizarre.
Hmm.
Huh.
I agree.
Yeah. Yeah, I'm ready to be wrong. It doesn't seem right.
But what would be repeated, right? Because like we're actually deduplicating off of 100% of this input, right?
Yeah.
This is the recursive call, right? Like 180. We don't have any other recursive calls besides line 187, right?
Huh?
So this is the only thing that could cause us to infinite loop right here.
Hmm.
Attempt place is not recursive, right? If we go in here, attempt place.
Nope.
Yeah.
And we only try to solve if we've successfully placed something. And we're returning false. It's not a solution. We continue this. Y plus plus X plus plus. Is it possible that like uh, I don't know, should we do new presence? I'm just worried about like are we actually clobbering some state or something?
Okay.
That's out there. I don't know.
It's fine. I think not reusing the same symbol is fine. Like, I actually kind of wish that JavaScript treated these arguments as const,
Yep. Yep.
or TypeScript did rather.
Oh, so it did eventually finish.
Oh, okay, it did. So maybe it's just slow, right?
That's really slow. Huh. 1 1. I want to see how often we're going back to the beginning. So basically, my question is, how often do we decide that the first present placed was no good, and we need to, like, oh, I guess we only hit this exactly once, don't we? Okay. Let me do 2 then. Oops. Huh, just doesn't save sometimes, does it? Oh no, I didn't change my. So it just takes a while to go through all these sub possibilities and decide to go back up. That sucks.
I am a little bit weirded out that like we were. I guess we don't know. You see, so what we don't know is like the path by which we took to get somewhere,
Mhm.
and so when it is like impossible, it's just kind of spinning, right? Um,
Right, yeah.
what is the impossible case? Is it that it doesn't fit? Like, can we say are there other like early out heuristics that we can say just like this shape literally has
Mm,
this many dots in it and we don't have that many dots left in the entire thing?
that's possible, yeah.
That's another pruning opportunity. It's kind of dumb because it's only going to
Mhm.
apply.
Yeah, only occasionally,
Yeah.
but yeah.
Um,
But like it's not a bad call. Like we could calculate how many things we need to place and how many board spaces there are left and like kind of always determine it.
there's also kind of like a broad phase hit detection that we can do where we can say that this region only has a certain number of open spaces left. And so therefore
Mhm.
don't even try to place in this entire region if you need this many spaces.
Right, like we could basically try to do like 3 by 3s overlapping one edge basically on each side and like determine how many spots will fit that.
Yeah. I think because you can kind of like slide a shape incrementally,
Mhm.
subdividing into 3 by 3 doesn't into 3 by 3 like
Oh, sorry.
chunks
I'm
doesn't.
sorry.
Yeah.
I was saying. I guess you would do it 2 by 2 would be the minimal size each one could take up in terms of placement in like some sort of optimal situation.
When you say each one, what do you what does one refer to? What does each one refer to?
Each present, like I think each present you could like potentially overlap one edge of each present with every other present if you were doing some like optimal uh
Yeah.
stacking fitting. This is pretty gnarly.
I guess the right answer though.
Yeah. and it eventually gets the right answer. And yeah. Well, we just start writing this on the input and come back tomorrow.
I don't think it'll ever finish. I literally don't think it'll ever
Probably not.
finish. Yeah.
I think that's right.
Um.
Yeah, I assume it'll blow the stack at some point.
Yes, absolutely. Like I like multiply it out, right? Like if you look at the input, why is the input
Yeah.
edited right now? What the fuck? I feel like we get random weird mutations under multiplayer. Sorry, not multiplayer,
Yeah.
but
No, I mean this is multiplayer. I agree with that statement.
under live share. Multiplayer is Figma's terminology, so I'm just got have that stuck in my head. Um, yeah, I mean there are like 35 things, and for each one of these things, there's like there's like 39 times 43 possibilities, or let's subtract a couple off of these, right? So there's like 35 by 35, let's say. That's already 35 times 35. That's already 8,000 different positions times 4 rotations, or 3 rotations, rather. Are we rotating too many times, by the way? Is the 4th rotation just the original one?
0, 1, 2, 3. We have to do 3 rotations, right? So that I think this is good. Yeah, we have to rotate. Oh, the the 0th rotation is nothing.
Nothing.
So no, I
Okay,
think
yeah,
this
yeah,
is
yeah,
right.
yeah. Okay. So yeah, we basically each for the initial thing that we like put in, it's gonna be like whatever one it was. It's roughly going to be like 25,000 things that we have to try just for the first placement, right?
Yeah.
And that will take this down to 34. And that is the first layer. That is like the first layer of your recursion. It has like 24,000 possibilities. So it will definitely blow out the stack,
Gosh.
right?
Fuck. Oh man, what a mess. These problems. What a pain in the
Well,
ass.
actually, it won't blow out the stack. The stack is only going to go so deep, right?
Okay.
The stack actually has a finite height. Because the stack is basically, you're on your current one, you place it, you decrement, and then you go to the next one. And then the stack only increases for every single placement that you make. It's just that the tree is really wide, right? The tree is exceptionally wide.
That is true. Yeah, it's just gonna go.
Yeah, the stack
for a
is
long,
basically
long
going to
time.
be at the height of the stack is bound to the sum of these presents, right? That's the deepest it's ever going to get.
Okay.
Yeah. So we're not worried about stack. We're just worried about runtime, right?
Yeah. But I am worried about runtime.
Yeah. So this is challenging. I think I'm getting jinxed by calling the last day the easy one. That's normal when you have 25 days.
Yep. Instead, it was the second to last day, which was mildly trivial.
Okay, so we need to actually think out of the box. I think that's like basically what it is we need to have some shower thoughts about how to optimize, right?
That seems right. Yeah.
So we
And,
have
like-
had shower thoughts about the other ones. Shall we cleanse ourselves?
Yes.
We need a new brain for this, right? So let's go ahead and
take us to 10B. Yeah.
Yeah, I'm gonna go ahead and like add this to. I'm gonna add day 12. And then I'm gonna just call this. Incremental progress? Question mark. Just so we have the record of today's thing. And now we'll move back to day 10B and see what we can get.
Cool.
If my push ever finishes.
Yeah, I mean, I feel like I want to read a Wikipedia page on Tetris rotation or something.
Right. Because I think maybe the insight that we're missing here is some kind of like, can we somehow pre-combine the shapes in a way that makes the search space much, much, much smaller, right? Okay, so we need to refresh our brains a little bit. 10b was about, it was another recursion problem. 10b was about pressing buttons. This is the one we did with Jim, right? And it was about joltage. It was that every time you press one of these buttons here, it increments the joltage for light
That's right,
0,
yeah.
1, 2, 3, and 4. So that means that the joltage state would be 1, 1, 1, 1, 1, right? Something like that. And then we need to basically combine button presses such that we achieve this level of joltage. Exactly.
And we're looking for the minimum set, right?
We're looking for the minimum number of presses. Yes, the fewest total presses that will get you there. And then the way that we combine all the answers there is we add up every single row, right? So each row is its own recursive search problem, right? So I'm still trying to download the problem back in my brain, but I think. Did we get
an insight, which was that?
Yeah.
I mean, your insight was, I think that like once you solve, you like solve for one joltage value, right? It's like solve for one joltage value and then eliminate buttons that include that number. So like you shrink the search space a lot when you do that.
Yeah. So what we do is we basically say,
Like basically like solve for the lowest joltage value, eliminate buttons, continue. And if you can't continue, you've got to do something.
Yeah,
like,
but I guess
go
I'm
back.
trying to figure out what the recursion is, right? Is there multiple
Yeah.
ways of achieving the same thing, or is there like? So I guess we want to first of all be clear about buttons and what is the container for these joltages? Is it a light? What is the terminology that the problem uses?
It's just it's a machine. A machine contains joltage.
It's a
The
machine.
lights,
Yes.
the lights
Okay.
are, we're ignoring the lights completely at this point. That was like part one.
Okay, yes. So, I'm trying to think of what the thing I was proposing was. I think maybe what it is, we figure out all of the combinations of button presses that will get us. We pick one machine arbitrarily, right? We find all of the possible button presses that will get us to 10 joltage in the first machine without exceeding the joltages over everything else, right?
Yeah.
And that will give us like a set of different machine joltages where the first one is 0, right? The first requirement is 0.
Yeah. Yeah.
I'm gonna ban someone who has been posting twice in our chat, real quick. Can I?
Weird. I haven't seen any chat posts. Who's posted in the chat?
It might have been a little while ago, but yeah, I'll just go ahead. It's stopped ringleader XHG56A.
Huh. I never saw that message come in. That's really interesting.
Okay, well, we'll just ban him. It's cool.
Do it. Fuck them up.
It's done. Okay. Okay, so what we're going to do is we're going to come up with all the different ways we can. We don't actually even need to know the path, right? We just want to find the. Let's say we have n different ways of reaching 10 for the first button. That's going to produce potentially n different states of machine joltages where the first one is 0, right?
Yes.
And then that becomes a reduced problem at that point. So for each one of those n things, we repeat the process. And that is, I'm claiming that is better than just like arbitrarily pressing these buttons in a bunch of different orders. I think that's what our current solution is, right?
Yeah. or we're like pressing them in like button order. I don't, but that's like not, that's not helpful, I think. Yeah.
Right. So essentially, what it is, it's going to be like the solve function, the new solve function is going to be solve of. I guess we still have this stuff. I guess that particular thing still looks the same. We have spec, we have joltages, presses so far.
Because we're counting total button presses. Yeah.
But we're trying to focus on a specific one. So our strategy for the recursion is a little bit different, right?
Yeah, because we want to take the first joltage and start
The
solving
first
for
non-zero
that.
joltage, even, right?
First non-zero joltage. Yeah.
Um,
And yeah, that's interesting too, because that like I'm just looking at the example, but like that limits there's only two buttons we can press. So like not only are we eliminating states, but we're also sort of like uh eliminating recursive possibilities.
so what the return value? I think the difference is that the return value. It's almost as if we don't necessarily want to track presses so far, but it's going to be. What we want to do is we like our input is going to be like the number of presses it took us to get to this particular state of joltages, right? And then there's going to be a bunch of those because we maybe took
Yeah.
a bunch of different routes to get there, right? But the precondition that we know about this thing here is that like the leading n number of machines are 0, right? I think that's roughly the idea that I'm going for.
Yeah.
And then we can just basically ignore the buttons that don't affect the machine that we care about, right?
That's correct. And we're eliminating, like if we start with joltage 0, we've eliminated every button that has a 0 in it by that point and created a bunch of states to get there.
Right.
Okay. I like this a lot.
So the question is that once let's say we have one of these things where like basically we get like, so it's almost as if we have like two different recursive functions. We have like an outer one that's like kind of controlling it and an inner one that only works on one of these combinations. So I guess the question is, what do we do once we have one of these? We have like an initial state which has a bunch of leading zeros for the first n number of machines. And I don't even think we necessarily need number of presses. We just need the minimal number that got us there, right?
Okay. Yeah.
So the question is at that point, what do we do at that point? We have all these other buttons. We can eliminate the buttons that don't change the first number, right? Or basically are greater than or equal to the whatever. Because this list of joltage requirements, either this can be represented in two different ways. Either it's represented as what we've added up to so far for those machines, or what the requirements are. I think the second one's better, right? We basically reduce the requirement over time because we are pressing buttons,
Yeah.
right?
Yeah,
And if any of them go negative, we know that possibility is not possible. That shouldn't be there. Right. So let me just start sketching something out, and I'm just gonna call this function foobar, and because I don't know what the right name for it is yet, right? So it's like target joltages, and it's gonna return, I don't know, a new set of target joltages where the first non-zero one in the input is now 0, in all of these outputs, right? All of these possibilities, right? So what we are going to do at this point is, I think, the question, right?
I admit I'm kind of lost here. Let's keep pseudocoding.
Okay, so target joltages is going to look like 0, 0, dot, 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 and then let's just say like 1, 2, 3.
Yeah.
Right?
Yeah.
And then the result will look like a list of 0, 0, 0, dot, 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 1, 3, 5. Right? We're going to have another... It's going to be a bunch of these things, and this is going to be like 2, 5, 9, 7, and then like... Because like the different combinations of buttons that we press are going to give us like... Sorry, it's actually going to reduce these. So these are going to be... I'm trying to think of like what a good... Let's just do 100, 103, 105. And then all of these subsequent ones over here are going to be reduced by like different amounts because we pressed different buttons to get there.
Yeah. Are we reducing one of them to 0 at this point to say like
Yes.
we've solved for so like is the first one of this 0? Or you're saying somewhere in the dot 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 we've reduced 1 to 0. Okay.
It's that there's one more 0 than there was before here.
Oh, there you go. Perfect.
Yeah,
Yes,
in fact, let me
okay.
just get rid of the dot dot dot. It's just confusing, right? Let's just assume that we have 5 machines here, or 6 machines, right?
Yeah.
So what we're gonna do is we're gonna say like, okay, you are trying to reduce the third machine down to nothing, right? And you can do that getting a certain number of button presses, but the side effect of that is it will have reduced these last 2 machines by different amounts, right?
Yes.
And then this will be like 4 presses. It doesn't matter what buttons you pressed, right? And this will be like 10 presses, right?
Yeah, and anything that goes negative on here, we're throwing out already. So we're saying that's already not possible.
Yes. All the negatives we've already filtered out. So that's the return value. So that is more or less the proposal. I don't know. Does this reduce the search space sufficiently?
I think it does. It reduces the number of random button presses. It reduces our button search space as we're recursing.
Yep.
So yeah, I feel good about this.
Okay. To make this recursive, I think we also need to say how many presses we did. So this is like 2 presses to get here, and that will serve this. This will be the basis of our return value, because these presses are just like the historical presses that it took to get to this particular state. Right.
Correct. Yeah, it's got to accumulate those. Yeah.
And that can be deduplicated, right? Like if you get to this particular state with n number of presses, that is like the deduplication that we can do. We can add there, right? Okay. Shall we try it? So what we know is that the first n number of these is 0. So like the const machine index is equal to... So first of all, we know we're done if all of them are 0, right?
Yes.
If target joltages dot every value equals 0, then we're done. And I guess it's an array, right? Or do we just print the number of presses? We don't know if it's minimal though, right? We don't know if it's minimal.
We just know that we've reached the end. Yeah.
Are we returning this or are we recursing? Like, should this just be a number? Are we returning the best thing that we got?
Mm, huh.
Let's try it like
Yeah,
this, and we'll see.
I kind of just like number. Yeah, yeah, yeah.
Okay. So now we want to know which the target machine is.
Hmm.
Find index. The value is the value that is greater than 0, right?
Hmm.
Okay, that's the machine index. And then the buttons that we can press are equal to, do we get a spec? What do we have in the constructor here? Honestly, the spec should probably be in the constructor of the solver. Because I don't think
Yeah,
that changes, right?
No, and I want to be able to access the button wirings. Yeah.
Yeah. This dot spec dot
Spec dot wirings.
wirings dot filter.
Hmm.
And then this is a wiring, and the wiring has to contain the index, right?
Yep. Yep.
Okay, so these are all the buttons that we can press from here on out, right? So what's our button pressing strategy? Do we press the same button repeatedly? I guess this going forward, this is going to look exactly the same as our previous recursion, right?
Well, if we're going for the minimal number of presses, I
Yep.
think we should press the button that has the most numbers in it.
The thing is that
Like
that doesn't. I don't
Like,
think
we
that
want-
the order that we do it matters because these different things have.
Like, I think we should go depth first on the button that toggles the most voltages going forward, because that has the greatest impact. Like, for minimal number of presses, every button with multiple voltages is saving us another press somewhere else.
Right.
Maybe.
Right. So I think I see what you're saying, but like, does that? You're essentially recommending a greedy algorithm of some kind, right? Let's sort of
Yeah.
like sort the way that we approach this.
Hmm.
Does that
It is an
guarantee?
optimization.
Yeah.
Yeah,
Does
yeah,
that does a greedy algorithm in this case guarantee optimality? Is basically what I'm saying. Is I'm not sure that it does, right? Because it might be the case that the right answer is that you don't press the one with the highest numbers at all, because it doesn't.
That's true.
It doesn't drop the other voltages down to 0 that you want, right? So, I guess maybe that's
Yeah,
my concern,
that's real.
right?
Yeah, and then there's like a question of, well, there's like a very different way to do the problem of, like, can you backtrack any of that stuff if you realize that you press something and you need to have one less on something else? Can you unpress a button? And I don't think we can tackle that right now. I don't want to tackle that right now. That seems like a lot.
Unpressing a button. It feels like a complication that you wouldn't have run into if you just tried all the button presses going forward into it rather than going backwards, right?
I agree. I think also a different optimization that we don't need.
Okay.
Okay.
So now we just need to try every single possible button press from here, right?
We want includes machine index. We also want it to not include
Negatives.
all the voltages that are already 0 for that button. Yeah.
Oh, that's a great point. Yes.
Yeah. Yeah. So the buttons get filtered down even more.
Okay, so
like-
machine
there's like an
index and then
exclude list,
0
right?
indexes, const 0 indexes
Mhm.
equals target voltages dot
Filter.
reduce.
Filter.
Well, we're trying to get the indexes.
Oh, that's fair. That's fair.
Accum, and then this is target index, right? And then we're gonna say, and the accumulator starts off as like this as a number array. And the 0 indexes are like if target equals 0, then accum dot push.
Push index, yeah.
I don't think that doing this in a reduce is useful. It's a little confusing. Const 0 indexes is a number array. And then for let I equal 0, I less than target joltages dot length I plus plus. If target joltages I is 0, 0 indexes dot push I.
Yep, I think that's clear.
That's a little
same lines of
clearer.
code, but
Yeah.
I like it better. Yeah.
Okay.
So this is then, and 0 indexes.
Yes.
Why are we unhappy? Oh, there we go. Great.
That looks weird. Yep. An argument of type button wiring.
Oh,
It's 0 indexes
need-
dot. It's w dot every. Or 0
Oh,
indexes
sorry,
dot
yeah, yeah, yeah.
every. Something like this. So for every 0 index, w does not include index.
yep.
We're essentially
yep, okay.
doing like they need to be disjoint sets, right? And so this is the big innovation of my whole proposal here is literally just these lines here.
Yeah.
So it has to be a button that will push us forward, but it can't be a button that will push us negative on anything.
Correct.
Right. Okay. And so now we go ahead and literally just like press every possible combination of buttons from here. Is that right?
Yeah, I think so.
Okay, so what's the loop? What is this interior loop here? For const buttons is just an index, right? Or it's a wiring of buttons. We apply the button to the joltages. What does apply do?
I think just gives us a new set of joltages.
Okay, yes.
Incremented.
And then we apply a single wiring. This is great. Okay, so new target is apply of joltage, target joltages, button. If new target dot any is less than 0, then we continue, right? New target has any type. Why?
What? No, it doesn't.
New target is a number array. Oh, any is not a function.
Oh, is it dot?
I can do not every.
Sure.
They all have to be positive or 0, right? For us
Yeah.
to,
Yeah.
And then we do like a let best equal undefined. And then the result here is just calling foobar again, right? On the new target and presses +1. if the best is not defined. I guess we can just do infinity here, right?
Yeah. I like that.
The minimum of best and the result, right? Then we return result.
Return best.
And then there is a dedupe that we can do, which is that if we get to a particular target joltage.
So how are you trying to do best? Yeah.
The presses don't matter, right? In terms of deduplication. How we got there doesn't matter. Is that right?
How we got there doesn't.
It only matters if we're currently getting there with a fewer number of presses than we did before, right? So we actually need to keep track of the best one over time, right? What was our memory before? Was it also like a map to the best possible thing? It is. So we're going to be reusing memory, right?
Oh yeah, we've got state key is just joltage.join. Yeah. Okay.
So we're going to say state key. How do we do a state key? We're just joining them. Yes. Sorry. You literally just said that.
All good.
These are numbers. Do they need to be comma separated? Can we produce the same thing twice? Because like 50 has a 0 on the end. Would we mistake that 0 on the end for a 0 in the next index?
Let's make sure. Let's put comma separated in there. I think that's reasonable.
Okay.
Yeah.
And then if the previous is memory, right?
Yeah.
It's this dot memory. What's that?
I said previous is comma. Join empty is comma.
Okay. Yes. Okay. Great. This dot memory dot get. I don't love that. I'm gonna add this in here. I don't love that there's a. I really don't. Like it's bad. Like this dot get of state key, and then if prev is defined, right? If it's not, if it's defined and prev is less than presses, less than or equal to presses, then we return infinity, right? We basically just don't have an answer. Like there's no point in pursuing this one.
Yes. Okay, cool.
Right. Because this will produce an answer that is worse, right? Strictly worse. And then each time we get an actual answer, we need to write it into the memory, right? If it's better, right? So if... Oh, no, this will just directly write it, right? So this dot memory set state key
presses. Yeah.
Presses. Okay.
So this is always an end solution. Do we need to also track intermediate memory?
Well, I think we need to. Well, we're gonna get a best one down here as well.
Yeah.
And the question is, do we set the memory here, or do we have to check the memory again to see if we hadn't gotten a better solution elsewhere? Right, because we're setting it in setting the memory in two different places. We're setting it in like line 102, and we might be setting it down here on like 129. And the question is do those fight with each other? Like, do we need to recheck?
Well, and like, do we... Setting it down here also implies that we have... Like, setting it after the recursion in foobar means that we've gone all the way to 0. Like, we won't get back from this without infinity or a 0 solution. Right? Like, res must be either infinity or a number at this point.
Yes.
So I think... So, like, memory is not doing much for us unless we like write it somewhere up here for like a partial state. Like we want to know that we've gotten the first two buttons to 0 in fewer presses or not. First two machines to 0 rather. We're not ending any branches early, which might be fine.
I'm not sure if that's true, or at least I think maybe because when I think of this tree, it's like fanning out into like a giant depth first thing, right?
Mm-hmm. Mm-hmm.
And you might get to like a button press where you do like button press, you hit button index 2, button index 4, and then button index 2. But you might have another tree where you hit button index 2, button index 2, button index 4. And those are the same thing, right?
Okay.
And maybe what you're saying is that you're never going to hit it in that sequence, maybe, because we're doing it in a deterministic order. But I think that...
Yeah, now I'm not sure. Okay, interesting. Should we run some example and see what we get?
Yeah, I'm still just trying to decide. We probably need to set the memory down here because we got an answer. Like if best is less than infinity, we have an answer, and then we need to basically set the memory. And so my question is, like, do we need to check the memory again to see if we've improved upon this joltage?
Yeah. Is that not the same as line 102, setting the memory?
No, because this is only setting it for when the joltage is 0. So that's for the target joltage when it's 0. But when we get down here, this is when the target joltages are like some other random weird number, right?
Aren't they always 0 by the time we've gotten on this side of this foobar? Though that's what I was asking. Like, this is finished recursion.
They're 0 in the recursive call that goes to 0, but they're not over here.
Oh, yeah. The
target joltages aren't being updated in this scope, right?
No, I'm dumb. Yeah. So yeah, let's do it there. I think you are correct.
Okay, and this is actually kind of, I'm actually doing a stupid thing here. We return prev. This is actually what it should be.
Okay.
Up here. Then we set the memory. So I think this is going to be redundant, but why don't we just check again? Actually, it's just state key, right? We computed this already.
Isn't this new target though? We've applied state key. State key is like unapplied joltages up to this point.
Again, we are trying to set the memory for the input.
Yeah. Okay. Sorry.
Yeah, no worries.
My brain's not recursing.
No, this is all. These are hard recursion problems, right? They're quite complicated.
Yeah.
Okay, so the previous, if the prev is defined and best less than prev, then this.memory.set state key prev.
Okay.
Otherwise, we return prev.
If there was a prev, we've returned already in this function.
Right, so we just set the memory here is what you're saying.
Yeah.
With best.
Yeah, I think so. Okay.
As long as it's not infinity. Or it can be infinity,
yeah.
Right? Like, I guess it doesn't really matter. Like
that would be the best, yeah. Though then if we pull that out of memory, we would stop recursing when we found that. So yeah, I think that's right. Okay.
Yeah. See, I think even my brain is getting kind of like messed up by all this, so it is confusing. So this is foobar. Is that just a replacement for recurse? I think it is, right? It's this dot foobar. This dot foobar, and then the number presses is 0. Is that right?
Mm-hmm.
And then solve does not have a
bold to
machine
wipe it
spec
out,
anymore.
but it's in Git, so yeah.
And then foobar is just recurse, right? Boy, I don't have enough context from last time to recall whether or not this is better or worse than before. Okay, so why don't we run on the example?
Let's find out. Yeah, 33. Fuck. 0 is not the answer.
Yeah. Are we properly incrementing? We are. Solve should probably throw if we don't get a non-zero. I mean, it's fine. Like, is this really the best we can do? This is just so complicated.
And we're never hitting prev either, so it's not like early outing on interesting.
We're never deduplicating, yeah.
Yeah.
Are we decrementing the target joltages? We do apply. Apply should be doing it, right?
Mm-hmm. Is there a valid button set?
Oh, we should be subtracting for apply, right? In this case, apply subtracts.
Yeah. Oh, Crazy Wolf just signed on to say day 10 is brutal. Day 10 is brutal. Day 9 was still more brutal.
So if we change this to minus, it doesn't matter. I think my idea was better than this one, but I don't remember what I was saying. Do I have it open? My previous idea? I think it's in Discord, actually. Where is Discord? Our Discord degenerated into a rant about CoffeeScript. Okay.
As so frequently occurs.
Okay, I said, what if something like this? Bullet point 1. I'll just copy this. What the fuck am I doing?
Yeah, just bring it into something.
Wrap. For a given row, pick their lowest or highest target. I don't think it matters picking. Figure out all the button press combos that will hit that target, minus those that will cause other targets to exceed their limits. Doing a per target search this way lets you limit the buttons you're searching over. Okay, no, this is exactly the same thing we're doing.
Yeah, okay. Yeah.
So we need to make it work, and then I think it's still a good idea, maybe.
Yeah. So here's the problem. We've passed in a 0 array. So in fact, if we're subtracting, we want this .spec .joltage target splatted out.
Okay, that's better. So this is still basically the same thing. Yeah. I mean, but this is correct.
But our buttons are getting filtered to nothing. So we just gotta fix the code.
Okay. Yes. Maybe line 86 is the suspect one. Is that right?
I think so. Yeah. I think I'm guessing that buttons are just not we're not pressing anything, so we're ending.
Yeah.
All right. So what do we think?
How you doing on time, by the way, Dom? We're getting 5 minutes to noontime.
Oh, yeah, let's give this another half an hour.
Okay.
So we want all buttons that have wirings includes machine index 0. And then, gosh, I guess we could step through this too. I forgot we have step through debugging.
Let's do that because I think we're getting a little bit confused between like different logging within an iteration and logging between iterations, right? So I guess we'll just do the first recursion.
Mm-hmm.
Okay, so our target filters are 3, 5, and 7. That's this one.
Great, love it.
We have nothing in the memory.
Mm-hmm.
It's not all 0.
Mm-hmm.
We're going to just do the first button, which is 0.
Mm-hmm.
And then our 0 indexes are going to be also totally empty, right? So let me jump down
Should
here.
be.
Wait, why is this not setting a breakpoint?
I don't know, that's weird. But
oh, it did. It just, I think the UI is just a little messed up.
Okay, so yeah, no 0 indexes.
No 0 indexes. Okay, that's great. Okay, so now we're going to filter this, and we're going to go down to buttons down here.
Huh?
And we know that they're getting filtered out, right? Buttons.
Yes.
Yeah, okay. Yeah, so we know that this expression is wrong. Okay, so we're going through every single wiring. Every wiring is a list of indexes that it's going to increment, or in this case, decrement, right?
Mm-hmm. So I think the first half is good. I'm skeptical of the 0 indexes.
Okay, so the 0 indexes is empty.
Huh?
So maybe we just need another check to make sure that 0 indexes is empty.
Yeah, what is every...
For an empty array, yeah. Is that always false?
Is that automatically or always true?
It's always true.
Okay, so that makes sense. So we're not actually, since we're unable to check...
So the not is the wrong thing, right?
We're doing not true. Well, and if there was something in 0 index, that might be...
So if 0 index has something in there, we want to make sure that the button that we're on does not press that button, right? That particular index.
Oh, yeah, so I think just removing the not is correct. Yeah. Okay.
That's pretty slow, though. It's kind of... I think we did better. Oh, are we still debugging? Is that the problem? No. I don't know. We did better than this on day 12A, right? Oh no, we never actually even finished. Did this run for the example? I think it did.
Wait, are you running day 12?
Oh, sorry. Day 12 is wrong. Day 10. Sorry. 34, is that the right answer?
It's 33.
Are we off by 1?
Somewhere. Yeah. And that's for 3 inputs. Oh, I hate it.
So we console log. Oh yeah, it should be off by 3, right?
If it was going to be, yeah, exactly.
So let's get rid of some of these redundant console logs if we can. There's a lot.
Uh-huh.
Gosh, there's so many of these things. Jesus Christ. I guess we kind of want to know which is which, right? So... Okay, 11, 12, 11. So which one are we off on? The first one. Oh, it's 10, 12, and 11, and we're kind of weirdly off on each one, right?
11? No, didn't you just say 11, 12, 11?
Yes, so we're off on the first one.
Yeah. Okay, let's take the example down to one line and figure
Okay,
out
let me
why.
just double check that the example is copied over
Oh,
correctly. The example, for some
oh yeah,
reason,
good.
again, has these like phantom text edits on it. Okay, so you want to take the input down to one line.
Yeah.
All right, let's get rid of these. Okay, so this should be 10, but it is 11, right?
Still 11, yeah. Hmm.
Are we eliminating a possibility that should not be eliminated through this?
Right, yeah.
Like, is the pruning too aggressive?
Maybe we can log our button presses. We're supposed to press 0, 0, 1 twice and 0, 2 once. I like that it gave us the full steps here.
We don't have that history right now, but we can keep it if we want to.
Oh, right, right. Hmm.
Oh, I think maybe this is too eager. I think I actually need to make this a little more complicated. I had something that was better before.
Yeah, I think checking against presses here is correct because we are otherwise accepting worse state.
Prev is less than presses, right?
Mhm.
Or less than or equal to,
Yeah,
right?
sure. Mhm.
That's it. And we don't need to set the memory here, right? Not here, because it's already been set. We're reading out of the memory. And did that do it? Yeah, that did it. Okay, that was the fix. That was the fix. Okay.
Cool.
I
All right.
feel like we kind of dodged a bullet on that bug fix. It was really easy.
That's what the example's for.
Okay, yes. Okay, so now we got to go to the actual input, and so after all of that, did this actually make it any faster? We'll see.
I hope so.
Yeah. Let's do this.
Or at least log what index we're at. Yeah.
Yeah, even the first one is just like taking forever. Okay, that means my brainstorm of this is not good.
Yeah. Did we make this worse somehow? I don't think so.
I don't think I think this was the same result as last time we tried, right? So to be clear,
That's
I
too
guess for
bad.
folks that are joining the stream now, this is our second attempt at this second puzzle on day 10. The first one, we had a more naive recursion solution where we were just trying every potential button press. This strategy that we're doing right now is a little bit more intelligent, where we're essentially just trying to zero out. We have like a sequence of targets. We basically are a little bit more deliberately trying to zero out each element of the sequence in that sequence. And that theoretically should reduce the search space. And I think concretely what it does is that it basically gives us smaller problems where, you know, if like the first few numbers in our sequence are all 0, that will let us filter out some buttons that won't get us there, right? Although if I think about it now, no, I mean, I think this is a good optimization. It's just not enough, right?
Yeah.
Because we're not even getting past the first item in the input right now.
That's pretty ridiculous. I'm surprised by that, but yeah.
Yeah.
Because it's only 6 items. It's not.
Yeah, and I'm pretty sure that everything in Advent of Code it's like possible to run it in like 70 milliseconds. You know what I mean? Like, I think that like
I think so.
there's just
Yeah,
some
exactly.
there's some optimization we're not taking advantage of here.
Yep. Yep. I mean, I wonder about.
Yeah.
I wonder about doing it from the lowest joltage number. Because, like, I'm just looking at this first problem, and, like, 23
Okay.
is index 2.
Okay.
And there's only a couple buttons that can do that.
Right. So what you're saying is like, let's try to speed run our way into that optimization as early as possible.
Yeah, man, I think there's something to the taking button presses away situation.
Yeah.
I wonder about that.
Yeah.
I think you eagerly take. I think you do a greedy algorithm on the lowest joltage. So you take the button that has two in it that has the most wirings and go from there, and that's your starting point.
The button that has most wirings in it.
Yeah, so like in this first example, like the second button has five wirings,
Okay.
including two. So like that presses more, it puts more joltages in, and I feel like that's sort of the greedy solution. Um, but I think to do that, you need to be able to unpress a button per my sort of like backwards approach. So kind of silly.
Okay.
I'm not sure it's better. I don't know if this is a real algorithm or not.
I I don't want to say that like it's not a good solution, but I guess I don't
It's harder.
see how the backwards thing finishes, right? Like what's the well, if you go backwards, is that not just another like recursion in the opposite direction, right?
It is, but I guess my thinking is that if you are greedily taking the buttons with the most impact, you're closer to a minimal solution at your starting point for recursion there.
Like I think the goal there would be to more quickly get to the best possible answer in the memory,
Yeah.
which is the same
Yeah,
thing
yeah,
as just
exactly.
trying to more quickly get to the. So I mean I think
Yep.
we can at least sort these buttons that we press by the size of them. That's a thing we can do here.
Hmm. Hmm.
Uh, so I think you suggested two things. One is that the index that we want to shoot for is the lowest of these.
Yep. Yeah, start at the lowest and eagerly pick the biggest button as we're recursing as two optimizations. I don't think that's enough optimization for this problem at all.
Yeah, I agree. But I mean, there are things to try, right? And I think they're
Hmm.
relatively simple in and of themselves. So we go
Yep.
for let
Yep.
I equals 0, I is less than target joltages dot length, I plus plus. If
Huh?
target joltages I is greater than 0, do we need a best?
Mm, maybe.
And target voltages I is less than the lowest, then the machine index equals I, and the lowest equals target voltages I. Does that make sense? If we
Yes.
go back to the example, I just want to make sure that I'm not breaking it, 33. Okay, so
Cool.
that does something. I don't know what. And then you're saying also let's sort the buttons in terms of like how
Hmm.
big they are, right?
Hmm.
B1, B2, and then we do B. We want the largest one, right?
Yeah, we want the larger length first. Yeah.
Okay, so that's that.
Hmm.
In fact, we could sort the buttons in the very beginning, right? And we don't have to resort them every single time.
That's true. Yeah, yeah. They could just always be sorted largest to
I
smallest.
don't think that this additional sort here is meaningful, right? It adds some small constant time to every single iteration. The
Yep.
question is does it reduce the number of iterations, right?
Correct.
And so I guess with that, I think you had mentioned earlier. Did you not say that this is probably not enough optimization? I
I don't think
tend
it
to
is. No,
agree.
not at all.
Yeah.
Yeah. Let's run it and see if we get any further. But none of that screams we
Yeah,
changed
we,
the
we need it to
algorithm.
be
We
like
just
literally a million times faster, right? Something
correct.
like
Correct. Yeah.
yeah. Okay, so I think what we're concluding to is we don't have the shower thought intuition on like how to what's cutting the Gordian knot here, right?
Yep. Yep. Okay. Should we? You want to step it back one more to 9B and then compare our solutions there?
Okay, we can definitely do that. We maybe take another 20 minutes to do that.
Yeah. Yeah.
So let's do it. I'm into it. I am gonna commit this git add day 10 B. Just so we don't lose the progress. 2025 node slash day 10 B. Work in progress. All right, so we're 0 for 2 so far today on hard recursion problems.
Yeah.
Day 9B, I have reasonable confidence in my answer, but it's wrong. It doesn't infinitely loop, so it's like failing in a different way. And Dom, I believe you have one as well, right?
I've got one. It's fast.
Yes.
Passes the example, fails the input. The classic.
Okay. Let me try running yours. So it's gonna be npx
Okay.
tsx day 9b slash dom main.ts. Runs on the example first.
Hello. Oh, read file. Yeah.
Why did... Okay, let's fix the library. Does not seem... Oh, we're looking for main.ts here. What we want is actually everything here, and then up to here is everything that is not a forward slash. Plus. And what is it complaining about? It is almost as if our forward slashes are not... Oh, they are special. Sorry. Because they're the delimiter. That's confusing.
They are the... Yeah.
All right. Well, I'm glad we fixed that. That's 24. And then if we go to the actual input, I wonder what result you get for my input, right? This is going to be running on my input.
Oh, you get to fix the import. My editor always strips the unused import. It's very annoying.
Okay. Okay, so that yields this. I'm actually kind of curious to submit this and see what happens.
Do it.
But if I run mine...
Yeah, what do you get?
I get this number, which is...
Bigger? Much bigger.
Is it bigger?
Is it a whole digit bigger? Yeah.
It might be a whole digit bigger. So mine is supposedly too low, right? So if I submit this right now...
Oh, okay.
Oh, this is the wrong day. Cross-pollination. Day 9?
Day 9.
Well, it's still wrong. I know it's still wrong.
Yeah, it's still wrong.
What?
Oh,
You gave an answer to recently? Oh, this is trying to...
the other problem.
It's trying to prevent parallelism across problems.
Yeah.
Yeah, there's no more global leaderboard. I guess there is regular leaderboards. They're trying to make sure that I don't cheat against my old coworkers.
I mean, I assume they don't want to have it be solved by you shooting requests at the server.
Yeah, I guess they're trying to prevent me from cheating myself. That's what it is.
Yep. Yep.
Okay. Take it on my word that this is too low.
Yeah, I believe you. So mine's way too low.
So yours
yeah.
is probably too low. Do you want to talk about your solution? Because I get 24 on... But the problem with this example is the example does not cover all the edge cases, right? That's more or less the issue.
Yeah, I've considered trying to construct a different example to like try to break some of this stuff out.
Yeah, exactly. Talk us through though. What was your approach?
Okay. All right,
I will follow you now. I'm going to use that feature.
Oh, incredible! Great. So my approach is For this shape, and let me copy at least an example in here so I can
Yep.
sort of point at something. 9. And this one. Okay. Okay, so for the shape, I am building a list of all the vertical lines and what their x coordinate is.
Okay.
So there's like vertical segments.
Yep.
And the goal is to run a span-based flood fill on the rect that we're trying to solve. And so if I was solving for like this corner to this corner, this sort of
Yep.
like
I'm following.
out of bounds, for each row, I'm going to take a point on the left edge and the right edge, and I'm going to search until I hit an edge here and search until I hit an edge here.
A span, you mean?
And just a span, yeah. And just repeat that for each row. And so in this case, I'm hitting a span that's inside my shape, and I'm checking that, like, does this span intersect with the space we're looking for or not?
Yep.
And saying like, hey, there's a in discontinuity in the shape I'm looking at, so it's a fail. Doesn't match. And there's some edge cases like, if you're checking the top row and you hit this span, we are able to say, that's okay, that's not in the shape, keep searching. Like this column is not a blocker. We want to look for one more span.
How do you, and so what's your logic to know that that's not a blocker?
Something pretty stupid. Like if the end of the span, because they're sort of top to bottom, is the top of our extent, or the bottom of the span is the bottom of the span is the top of the extent, or the top of the span is the bottom of our extent. So like based on directionality, is it touching the top or bottom edges, and that's okay.
Okay. And then I think what we're concluding is that this is very aggressively hitting false positives in terms of the edge checks.
Yes.
Right.
Yes. So I think I want to construct a different example that maybe has other constraints, but I think this should cover U-shaped everything.
Right.
And is incredibly fast, which is great.
Yes.
And yeah, so the search is just get any 2 points, take what am I doing? X checks is just the list of X indexes in the puzzle that have a vertical at all.
Right.
And then filtering those two ones above the min extent and below the max extent and checking those directions separately. So it reduces a set of like thousands and thousands of verticals to 20 each.
Right.
Like only things that could possibly be within bounds of the puzzle, because we're also looking for like, do they even cross the Y values of the rect we're looking at?
Got it. Yes.
So it's very fast and very optimal, except it's incorrect.
Okay. So mine might be faster and simpler, but I don't know if it's correct. Or I guess correctness is a question for both of ours. I'm saying mine is faster and simpler just in terms of what it's looking at.
Yes. This was like a pre-work intensive version.
Yes. No, don't worry about it. I don't know which one's going to be. Like, the thing that matters is which one's correct. So, but let me just explain the algorithm for mine. So the idea here behind this one is that I basically am making a couple of claims, right? I'm just use the scratch text buffer. I don't need to comment anything out because I'm in a scratch text buffer. So one of the claims that I'm making is that if we are in a particular rectangle, and let us say that the rectangle is this one, what I'm saying is that this forms like 4 edges of a rectangle, okay? And the assertion that I'm making is that if every point around the perimeter of this rectangle is like inside the overall polygon that we're trying to hit, if every single point of the perimeter is in there, then the entire rectangle is in there, okay? So this is a little bit of a non-obvious point in my opinion, right? But the reason why I say that is that I want to say that the target polygon that we're trying to draw our rectangles on top of has no holes in it, right? There's no, like, it's not a donut. It doesn't have any lakes or ponds in it or anything like that. Okay. The other thing,
and
yeah,
lakes and ponds impossible with the data set, right? Because it's a contiguous line.
exactly.
Of,
Yes, it's a continuous set of vertices that outline the outer perimeter of something. Okay. So if you don't have any lakes or ponds or holes or anything like that, the only way that you can get a piece of this rectangle that is off of the polygon surface is if there's a discontinuity in one of the edges, right? So if we had a U shape, which I feel like I had in some of our notes here,
Yep.
and I think we have determined that there are U shapes in this output, right?
Yeah, I mean, you found one in yours, and like I didn't SVG mine yet, but like I don't know if it's the same
Yeah.
U shape or if they rotate it. I think it shouldn't matter though.
Right. So, let us propose that we're looking at, actually, I don't even think this is a particularly great example, but let's, like, if we're looking at, like, this rectangle here, this is the only way you're going to have something inside the rectangle that is not on the target surface is if one of the edges is broken somehow, right? Essentially, you have a U or a concavity that is dug into the rectangle. That's the only way that stuff inside of the rectangle is not going to be on the target surface, is if one of the edges has a concavity in it, right? So that's why I'm saying you only need to check the edges, right? So I think that's like the big optimization for my solution, is that if you just look at the points along the perimeter of the rectangle and say that they're inside the target polygon, then you're good, right?
Now, how are you checking that they're inside though?
Yeah. Okay. So that's the next question. Okay.
Yeah.
So my main data structure is very similar to yours in that I have this notion of a span, which has a minimum value, a maximum value, and a cross-axis position. So what this means is that for a horizontal span, you have a minimum x coordinate, a maximum x coordinate, and your cross-axis position is what your y coordinate is, right? And you can use the exact same data structure for vertical spans, where you have like a minimum y coordinate, a maximum y coordinate, and then your cross-axis position is on the x-axis, right?
Okay.
So you and I have the same exact concept, right? And so what we do to pre-process the input is that I called them the vertical borders and the horizontal borders, right? We are basically collecting in the horizontal borders this thing, this thing, this thing, and this thing, and then so on and so forth. I think you get what I'm.
And it's always equal number of both every time due to the data set.
Correct.
Right? Yeah.
Yes. And then what we do is you ask the operative question, which is like, let's say we have an outline of something. How do you know? How do you know whether or not it's inside or outside the target surface? So what I do is I kind of go, let's just say we have an outline that's like this. I'll use stars. Does this think I'm in code right now? That's why it's giving me squiggles.
Oh, weird. I don't know. It doesn't on my side. It's not parse this as anything.
No, it's okay. It's trying to help.
Text, yeah.
It's struggling. Okay, I think I need some prefix spaces. That'll help me. Okay, so we have this thing here. And so what I do is I'm going to go edge by edge. So at first I have this inner iteration, which is just like, okay, for a particular rectangle that we're looking at. Did you do this structure, by the way? Did you iterate over every pair of points and create a rectangle?
Yeah.
Okay, so we have the same outer loop, which is just like for every rectangle that we have. What I do is I just split this rectangle into like a minimum x position and a maximum x position and a minimum y position and a maximum y position. And I always start at the top left corner, right? I call that out because sometimes the rectangle that you're actually iterating over is defined by like a point in the upper right and the lower
exactly.
left, right? So
I think I have the same optimization where it's just like, top left, bottom right are the extents of this object.
So let's say we're just looking at the top edge, right? And I'm trying to say, is every single point on this edge inside the target polygon? So what I do is I grab this one point. I'm just starting here, and I'm going to be I iterate over every single edge, so the math is going to be a little bit different for each edge. Because, like, for example, in this one, we're going to be looking at those spans that are outside of this thing. And for this bottom one, we're going to be looking at spans that are outside of this thing. And what outside is defined as is going to be a little bit different, right? Because the directionality is different. Similarly, for like the left and right edges, we're looking at the vertical spans at that point, or the vertical borders at that point. So what I say is, I'm on this point, so I'm going to break this edge up into chunks. And what those chunks are, I'll say in a second, right? But suffice to say, we're just breaking it up into chunks. So what I do is I say, for this particular point that starts my current chunk, what are all the vertical borders that I am quote-unquote inside of? And for the top edge, inside means above. Okay, I'm going to use a different character here. We might have an arbitrary number of these things, right? Because it can be U-shaped, right? I think this one needs to be like this. And let me make so the idea is here we have these spans stored in a data structure, right, which are the horizontal spans. And I'm basically saying at this point, what are all the spans that overlap with me, right? And are you following so far, like how this works?
Yeah. So are those are literally above? You're saying those are above you in the
Those
y
are
coordinates,
above
like
or coincident with this.
Yeah.
They
Yeah.
might-
Yeah. Yeah.
Okay. And then I say, if there's an even number of these things, okay, this is where it gets a little bit hard to imagine. If there's an even number of these things, I'm actually outside, like this top edge is actually outside of something, right? It would be like, in this example, I would be like out here for, actually, we don't have a great example that demonstrates this. Let me draw a picture that will demonstrate
No,
this.
that does. If on that point, you're saying there's two above that point.
I'm saying that we have something like, something like this.
Okay.
I'm making like another kind of peninsula here, right? So let's say we're down here. We're getting the number of horizontal spans that overlap this point. And I contend that there's 3. There's this one, which literally overlaps it.
Okay.
This one. And then this one up here. Right? That is an odd number of them. Right?
Okay.
Now, this example is a little bit weird because we're cherry picking a rectangle that starts, that actually has a vertex in the upper left. But again, we might have the version of the rectangle that kind of goes the other direction, right? Which means that we might have a top edge that starts outside of the polygon surface, and we need to be able to account for that. And I'm saying that if there's an even number of borders above that, including 0, I'm counting 0 as an even number, right? Then you are outside the polygon, is what I'm saying on that point.
Okay.
So basically, the query that I'm doing is like, for the current point that I'm checking, give me all of the horizontal borders that are that are above me, that have my same y position or above, which is, I think, in this kind of like map, it's like smaller y positions, right? It's less than or equal to the current cross-axis position. And if there's an odd number of them, I'm inside the polygon. If there's an even number of them, I'm outside. This is actually how you can... I think a similar heuristic is how you can tell whether or not a shape is concave. Like, you do like a ray cast, and you see how many edges you cross. And you count, you do like an even or odd thing. So it's a similar type of calculation, right?
Interesting.
Okay, take it on maybe you can. I don't know if that's actually a correct assumption or it might be off by one or something like that. But like
I gotta
if you
think about
take
that, yeah.
if you take that at my word,
Yeah.
the next thing you do is you find the nearest overlapping thing and you go to the end of it going rightwards, right? Because we're at the top edge and we go rightwards. Okay. So we're on this one here, like line 35. We're on this first corner thing, and we go up and we see. Let's say we count an odd number of things above us, right?
Mm-hmm.
That's saying that we're inside the polygon. So now I'm going to go to the innermost one, and I'm going to go to its maximum, which happens to be this, and now I'm going to start the search again. Okay, so now I'm going to basically say, what are all of the things? Oh no! Actually, go to the. Sorry, there's actually it's subtle. What I'm going to do is I'm going to go to the innermost border that is right above me. I'm going to go to the end of that one, and I'm going to add one, right? Because that, like, I know basically like these 2 points on my current edge are inside this innermost edge that is inside of the polygon. Does that make sense? And then I add 1, and now now the question is, are all of these points inside of the polygon?
Okay, yeah. So you're checking one by one. Okay.
And we
yeah.
rinse and repeat, right? And so
and the failure case for the top edge is something dipping in, basically.
Yeah, and something will dip in when there is an even number, which, for example, we will lose this
right.
one, right? Like this one,
exactly.
this one will go away. Right?
The count will change because you've lost a top. Yeah, interesting.
Right.
That makes sense.
And so when I say that this one is quote unquote simpler or quote unquote faster than yours, I'm only saying that I'm checking fewer points. So I'm trying to be very, very literal and technical. So I'm just checking fewer points. Whether it's more correct or not, I don't know, because obviously it's not working, right?
Yeah, I was not offended by that statement.
Yeah. Okay, cool. I just wanted to make sure. I just wanted to make just a qualitative comparison of the mechanic. So the sort of subtlety here is that like the math and the directionality is different depending on what edge you're looking at, right? So for example, like you're on the bottom edge, you're looking for stuff that has y coordinates that are greater than this, and then similar, like you're looking at vertical spans on the sides. And so if you look at the structure of this check, it literally says, I'm going to check the top edge, I'm going to check the bottom edge, I'm going to check the left edge, and I'm going to check the right edge. If any of these are outside of the polygon, then this particular rectangle doesn't work. And then we continue, right?
That's interesting.
Yeah.
But and this also fails. It's bullshit. Okay.
Yeah. Huh. It also fails. I do get a big number, and like I think what you were getting at before is like how do we actually improve upon these things? And then we have to check smaller edge cases.
Yeah, so I think maybe we can try to construct a antagonistic example for this one.
Yeah. Because in both of our cases, we are pruning some thing that we're basically eliminating. Yeah. We have false negatives, right? In our checks.
And we both do. I've got more than you clearly because my number's way smaller. Yeah. So interesting.
And
okay.
What did we say that this looks like? There's an SVG that I do not continue to have, but I will maybe bring onto stream real quickly.
Oh yeah, let me run that on my input too. I'm just curious now.
Yeah. I know we said no AI, but I did, when I was researching this problem or thinking about it, make a little AI program to generate an SVG file that looks like this. And this is what my solution looks like. Or not my solution, my input looks like this. And we were basically trying to figure out, pick a vertex, pick any pair of vertices in this weird jagged shape, make a rectangle out of them, and then if that rectangle is fully inside the blue color, then we want to find the largest such rectangle. And I am clearly missing some case, right? There's something that I'm missing. If I just eyeball this, can I open this in preview? Is that possible?
You should be able to, yeah. Yeah, I mean, like the I can see the biggest one. It's like above or below this big line, and then like sort
I
of
don't think
as
preview
much
can.
interior space as you can get.
I don't think preview can handle SVGs.
Really?
Or this
I
is a
don't believe
ping.
that.
This is a ping. How come
Oh,
preview
well, it can
can't
definitely
open
handle
it?
that.
Because why is it even opening? Oh, you know what? It's probably because it has a URL on it. I think it's just because the extension is weird. Thanks, macOS. Foo.ping could not be opened. Is this actually a ping? Is it an SVG? It says ping here.
You're outputting an SVG. I don't know where you're getting the ping.
The ping must be. Oh, you know what? I'm in Discord. I'm looking at a
Uh,
Discord image. So, I wanted to open this up in preview because I can draw on it, right?
yeah.
So you are saying that like you can kind of see the rectangle. Where were you saying it
Uh-huh.
was?
Oh, it's got to be. It's like touching the center line for sure.
Are you sure?
I'm pretty sure.
If it touches the center line, that means it has to have something that is that high. But the problem is that if we zoom
Oh, that's a
in,
good point. So I think touching the right edge of the center line.
potentially yes. So something
So
down
that's a corner,
here.
and then the left corner is you can sort of yeah, and like bring it in a little bit, something like that. That's my guess.
Uh,
Yeah.
well, that means that there would have to be a vertex somewhere over here, right? Which there
There
might
is on
be.
the bottom left corner. There is. You just pick one of those.
Yeah, but they have to be adjacent. They have to be opposite corners, like diagonally from each
Yeah,
other.
that's what I'm saying. So
Okay,
the
yes,
corner of the
this
cutout
thing.
and the bottom left corner somewhere.
Yeah, it's
Yeah,
got to be one of these things, right?
I think that's the largest shape. Yeah, and sort of
Or
like
one of
it's
these.
nice. The right edge has a boundary for you when you
Well,
cross out of the shape.
it's got to be. Yeah, yeah, it's got to be something like this. It's probably something of
Mhm.
this nature, right?
Yep.
Um,
Yep.
I guess locating this particular line might be interesting. I don't know how many vertices are along this center line. I wonder if we could just eyeball it in the input. I know we're a little bit over time, but I just want to see where this takes us.
See if you can
Uh,
figure it out. Yeah, yeah.
um, what's this one? Like, do we see a giant discontinuity on the x-axis anywhere here? I guess these are sorted, so
As I recall, it was pretty obvious. I remember just like seeing this and being like, "Oh,
does your input look the same?
roughly, yeah."
Yeah, it's basically a semicircle, or it's like a
Oh,
a
sorry.
coin.
I haven't. Yeah, I was just about to run the script on mine.
Okay, yeah.
Hmm?
When Roy said something, Roy talked about his solution. He said something had to like involve spirals. He apparently got it, so Roy figured it out.
Really?
Yeah.
Oh, interesting. Interesting.
Okay, so here's the jump.
Sorry, how do I run this? Just npm run polygon.ts?
I don't know. I think
Oh,
so.
okay. Oh, probably node polygon. Ah.
I think it needs to be in the same, like the input file needs to be in the same directory
Oh,
as.
yeah. Sorry, it's npx tsx because it's TypeScript. Okay.
Yes.
Oh, yeah, mine is nearly identical. Same cutout and everything.
Okay. So if you look at where I'm at in the input, you can see where you can see where the big jump is, right? This is the.
Yeah.
So
There
there are
you go.
not multiple
Absolutely.
points along this. So I think what you're saying is
Nope.
that if I bring up the image again. Fuck me.
It's like it's one of these two corners, right?
Yeah, one of these two corners has to be involved, right? And in my case, it is. Actually, it is. If you look at the like this corner is involved,
Mm-hmm.
and this is the upper corner.
Mm-hmm.
God, where's my image? Where did it go? Is it on the desktop? Did it go in the desktop? Oh, here it is. Ooh, I don't like this. Okay, so I think what my thing is claiming is that the best one is above the fold. It's picking this corner.
Okay. And like totally, totally possible. Yeah.
And it's doing something of this nature, right? But
Mhm.
somehow I'm like off by a tiny bit, right? And it
Yep.
could be that I'm not doing the bottom one down here, right? Like, did I do the bottom one
Incorrectly. Yeah.
incorrectly? Yeah.
Right. Like is I think for both of ours is our check edges either your raycasting or my uh different span checking raycasting basically. Like yeah, we're missing some edge or we're throwing something out that shouldn't be.
Yeah. Yeah. And I haven't figured out what that could be yet. I wonder
Cool.
if
All right.
mine only looks at the top half. That would be a really nice problem, you know, like if that was the issue or something. But I don't think that's the case. Like I stared at
Yeah.
this like the corner iteration or vertex iteration for like 5 minutes. I'm like, is this right? Is this right?
Hmm. Ugh. Okay. I'm gonna try to construct an example for this because that must be the way.
Okay.
I wanna know what edge case I'm fucking up.
All right. Well, I think that's going to be it for today's stream. And maybe I think this is the conclusion of our Advent of Code streams for this time around.
Quite possibly.
Yeah, like basically we're at the point in Advent of Code where it's just going to be grinding stuff out. And I think I'd be happy to continue pairing on this stuff just because two brains are better than one, but we don't need to do that on stream, right?
Yep. Yep. Yeah, I wanna keep coming back to these and maybe see what we can solve still.
Okay.
But
Yes.
yeah.
All in all, not too bad. I think that like the harder problems in Advent of Code every year are always like I remember when I streamed this last time, it took me like 8 hours to solve some of these problems, and I don't think we've gotten to anywhere near that time
No,
for
no.
any of the
Yeah,
things we've worked on, right?
I feel like we've scratched the surface of a couple of them, and this is. I kind of wish this difficulty had been spread out more because I feel like through day 8 it was like these are 20-minute problems, and now it's just like, come on, man, what are you giving to us here? But
I mean,
these are maybe 20-minute problems if you have the right insight. They're also very fast. So,
Like
yeah.
any kind of game development, and I would call Advent of Code a game.
Mm-hmm.
It's really hard to tune difficulty. It's very easy to
Yeah.
make something that's too easy or too hard, right? And I think
That's so real.
it's the same. It's the same thing for these types of puzzles. I'm trying to think of what the most bullshit day is. All of these ones, I think
In
nine.
this year?
What's that?
In this year, you mean,
This
or
year. Yeah,
ever?
this year. What was the most bullshit?
I so far it's 12.
I think 10B,
and
10B and 12 are equally hard. They're both
Yeah,
they're both
nine
stuck.
9B I think we've cracked, but yeah, 10B and 12.
Yeah.
Is there no 12B? Is 12 always one part? The final day always
The
one
final
part?
day is usually one part. I don't know.
Okay.
Yeah, usually.
We'll
Well,
see.
it's two parts, but the second part is always a button click. It's a kind of like
Oh, cute.
Yeah.
I love it.
yeah.
I was talking with a friend about this morning. And he said he heard a rumor that day 12 has input specific shortcuts. So like we might need to pre-optimize based on our input shapes.
I think that's right. And I think
Yeah.
maybe we can leave the final comment I'll make is that Dom Bench 135. Congratulations. Do you have a whole weight set in your house?
I do. I ordered 300 pounds of plates and bars to my house.
Man, I gotta move to Connecticut. I gotta move
Yeah,
to
yeah, I
Connecticut
got a
and have a
basement.
house. You know what I mean? Like, I would love to have my own set of weights at home, so I
It's
don't
pretty
have
good.
to. It's another reason why yet another. It would give me yet another excuse not to ever leave my house. I could just hermit here.
I mean, yes, and I work out more because all I have to do is go downstairs. It's not bad.
The irony though is that my gym is like a 5 to 10 minute walk from my house.
That's true. Berkeley's
Sir
really
Nolton's
walkable.
in Berkeley, right? I work at Strong Island Fitness on MLK.
Oh no, he's in St. Louis.
he's in
actually.
St.
Yeah,
Louis.
He didn't
Okay,
know
yeah,
anything. Yeah.
Oh, okay. You know what? The reason why I thought that is that you came to Berkeley and were able to work out with Sir Gnarlton. Like,
Exactly. Yeah, we did video training.
so
from
it's
both
just remote
coasts.
everywhere. Right. So Sir Gnarlton is everywhere all at once, right? I think that's a fair thing to say. Yeah.
He's working from home. We gotta make him put some office time in.
So I need to buy a house in Connecticut. It's
It's pretty good out here.
Yeah, although it's probably not twice as expensive as it was when you moved out there.
It's more expensive than I moved out here, but I go to New York every weekend. Could be worse.
Yeah, it's pretty
It's nice in
good.
New York too.
And then I just have to be prepared to replace the heater for tens of thousands of dollars
Yep.
every once in a while.
Pre-
Right.
Prepare to spend money on oil or heat pumps. Yeah.
Did you not have a situation where like you had a big leak or something?
Oh yeah, I had a sewage leak in my basement. Like it
That
was
sounds bad.
disastrous.
That sounds bad.
Don't own things. Yeah, I mean
Okay.
there's a flip side to owning stuff, which is I had to get someone
Perhaps
to
I
clean
will
sewage out of
not
my basement.
own my apartment building actually had I guess kind of a sewage leak. I think
And it was someone else's problem.
it was somebody else's problem, and it got taken care of relatively quickly. So I'm thankful that
That's
my
nice.
landlords are attentive to that thing. But I didn't
Yeah,
have to
well,
deal.
waiting makes that so much worse. It was shitty.
Yeah, yeah. Okay, well, that's it for Jeff and Dom versus Advent of Code 2025. I believe the score is Jeff and Dom 0, Advent of Code 2025 1.
Yeah, or like I think it's 9-3 right now. We've beat some of its puzzling machinations.
It's true. I guess there are 23 puzzles if you add them all up, and we have gotten
Oh, that's
20.
true.
We're 20 for 23. Okay. All right.
That could be worse.
Well, that is it. We also talked about a lot of video game stuff too, which is good.
Yeah, that's
I want to eat lunch, play video games, and watch the new Knives Out movie. All of which I can do now that I'm not doing Advent of Code on
Exactly.
Twitch
What are you gonna play?
anymore. I am going to play Ghost of Yotei. However, if somebody bothers me and wants to try to get me back onto Arc Raiders, I can do it.
Tempting. Okay, we'll see how my night goes.
I think
I'll
the other
text you
game that
about
I'm trying to play, let's do this right now,
Yeah.
is potentially Final Fantasy Tactics, the remake that came out this year. Have you heard of this?
Oh, I mean that's a good you game. You love tactics.
I do, and yet this is going to be a crunchy. It's going to be like a crunchy PS1 era. Like this game came out in '97, right? So it's going to have like 1997 quality of life to it, which sounds pretty savage. Actually, I think it goes from
Yeah.
like being trivial again on the subject of difficulty. It goes from being trivially easy to being like you're outnumbered and you get like completely ganked by the scenarios like immediately. So we'll see. But I've heard the script is good, and I think it's totally voice acted. And I don't know. I'm
Yeah,
a
I
sucker
hear-
for these kinds of things. I guess
I hear they added like difficulty levels too, like so like you can tune the grind.
is it Ogre Battle or is it Ogre?
Also, it's got a
Tactics?
voiceover. This looks nice.
Yeah. Ogre Tactics also supposed to be really good. Maybe this is another one to do.
Oh yeah, I love the Ogre series. I think I played that on like Super Nintendo. That's a classic.
Yeah. The one I played most recently a couple years ago is Triangle Strategy, which I believe is one of the best games to play on Nintendo Switch. It's very, very good. And it's a similar type of thing, and it has like it's designed by modern game designers, so it's going to have a very modern sensibility to it. But it looks almost exactly like Tactics Ogre.
That is nice. I think they have a shared pedigree, the Ogre and the Final Fantasy Tactics games, like a similar developer or something. Or
Yeah, I think certainly this remake might be on the same engine that Triangle Strategy's on.
that's Square Enix. That seems right. Yeah.
Okay,
Interesting.
John.
Well, that sounds fun. So enjoy.
Yes. Thank you for joining me on this Gonzo programming stunt.
Oh yeah, it was great. I'm glad it's half of December now. All of
Yeah, it would have
December
been
this
really
time.
hard. I don't know how I did this. The way that I did this in 2021 is I had a full-time job, but my boss was me, and I could set my own schedule. That's how it happened.
Yep, works out well that way.
Yes, very much so. All right. Any last words from the chat? Nice to meet you, sort of, Jeff. Keep up the good coding and the exercise. Excellent. Okay. All right. Nice to meet you too, Sir Nelson. Thank you for joining us on the stream. And maybe we'll die in Arc Raiders together at some point. Looking forward to it.
That's how most games end.
Yes. Okay. Take care, everybody.
All right.
We're out.
See y'all.